evaluate each expression. So first of all, we could try to do this directly. If I tried to do this directly, I would have to know 9 to what power is 6? Is 6 on our powers chart for 9? No. I have no idea what that answer would be. So we can't go about doing that. We can't do 9 to what power is 72? Also not on our powers chart. But maybe if we combine this to be a single logarithm, some things might simplify and it might work out nicer. So first of all, if I try to combine this as a single logarithm, I can put the 3 in as an exponent. And then I have a log minus a log, and the bases are the same. So I can divide. Now, I know what 6 cubed is. 6 cubed is one of the ones that's on your powers chart that you may not know off the top of your head. You might have to do some mental math to figure it out. But I don't want to write that 6 cubed is 216 up there. And I'll show you why. Because when you're simplifying, okay, how quick can you simplify 216 over 72 to its lowest value? Maybe not super quick. So I want to show you some simplification things that are kind of helpful. Okay? Would you agree that 6 cubed is 6 times 6 times 6? And 72 is 2 times 36, which happens to be 2 times 6 times 6. Why is this helpful? Well, without having to do any big multiplications, I could cancel out or simplify all those 6's. What would that leave me with? Just 6 divided by 2. Which is log 9 of 3. Now, if you can do this in your head, perfect. 9 to what power is 3? If not, okay, if you can do this in your head and get 1/2 perfect, because an exponent of a half is the same as a square root, and square root of 9 is 3. So you have to know those exponent rules of fractions or square roots or cube roots and so on. Perfect. If not, you might have at this time said, I'm going to let x equal log 9 of 3. I'm going to change this to exponential form. My base is 9, my exponent is x, my answer is 3. And then how do I solve these equations? Is 9 and 3 on my same chart, powers chart column? Yes. I can write 9 as 3 squared. And this is 3 to the 1. And so 3 to the 2x equals 3 to the 1. So 2x would have to equal 1, and x would equal 1/2. That's a lot more extra green work than just writing 1/2 as the answer, but both is fine. But if you know that the square root of 9 is 3, and you know that a log is solving for an exponent, this is asking 9 to what exponent here would be 3. 9 to the 1/2 equals 3. Write that off to the side. Do you agree with that? 9 to the 1/2 is equal to 3 because the square root of 9 is equal to 3. Okay, part A. So we couldn't do things directly, so we combined it as a single log to see if when it simplified, we could do it directly. Looking at part B. Again, I don't know 4 to what exponent is 6, so I might try to combine these, I'm going to put the numbers in first. Anytime you have numbers in front and you want to combine, that would need to be done first. Now I'm adding and subtracting, and all of those bases, all of those logs have the same base. So I can combine this as one log. What's going to go in my numerator? 6 squared and 12. What's going to be in my denominator? 3 cubed. Well, 3 cubed is 3 times 3 times 3. 6 is 3 times 2 times 3 times 2. And 12 is 3 times 4. Two times 2 times 4 is 16. What's log 4 of 16? Can we figure out that exponent? 4 to what exponent would be 16? It's 2. All right, so now you can do 14, 16, and 15, and also number 13. I will get your test ready so that we can go over it.